this segment, we're going to talk about the different versions of HR diagrams that you will see. The most commonly drawn version is the luminosity at the surface of the star versus the temperature at the surface of the star. The luminosity of the star compared to the luminosity of the sun is typically plotted on the vertical axis, and on the horizontal axis is the surface temperature of the star in units of Kelvin. Luminosity increases in the vertical direction, whereas temperature on the diagram increases to the left. Let's put the sun on the diagram. We know that the luminosity of the sun is equal to 1 solar luminosity. So if we put a 1 on the axis over here, and we come across, then the sun would be located right about there. The surface temperature of the sun is around 5,780 Kelvin, so we can put this temperature on the diagram that locates where the sun is. So if we just draw lines, you can see that's where the sun is located. Colder temperature stars are on the right side of the diagram, and hotter stars are to the left side of the diagram. Now let's say a star has a luminosity that is 10,000 times the luminosity of the sun. Since we see 4 zeros, that's the same thing as 10 to the 4th times the luminosity of the sun. And so we put 10 to the 4th right there. If another star, say, had 100 times the luminosity of the sun, well, we only count 2 zeros, so that would be 10 to the 2 times the luminosity of the sun, and that number would appear right there. Similarly, if a star had 0.001 times the luminosity of the sun, similarly, if a star had a luminosity that is 0.01 times the luminosity of the sun, well, that's the same thing as 10 to the minus 2, because you have to move your decimal point 2 spaces over to the right. So it would be 10 to the minus 2 times the luminosity of the sun, and that value would appear right here. Similarly, we can put in 10 to the minus 4 and 10 to the minus 6. Now, instead of comparing the luminosity of the star compared to the surface temperature, we could instead change the horizontal axis and compare the luminosity of the star to the color of the star. After all, when we see in this image from your textbook, we see that stars come in different colors. So instead of temperature, let's add another axis and compare the luminosity of the star to the color of the star. And we're going to put red down here on the right with an R, and then we'll put in the other colors of the rainbow. O for orange, Y for yellow, G for green, B for blue, I for indigo, and V for violet. So as you can see, we have our Roy G. Biv rainbow of colors written from right to left, where red is on the right side or the cold side of the diagram, and violet is on the left side or the hot side of the diagram. So when we look at this image, and we take a look at the red star, let's compare that red star and put it on the diagram. Well, the red star would be on the right-hand side or the cold side, and because the object appeared bright, it appears bright, we would put it in the upper right corner. Now let's go look at a blue star. So here's a bright big blue star right there. And since blue is a hot color and it is bright, we would put the blue star more in the indigo and violet region of the diagram in the upper left. Now, instead of comparing luminosity and surface temperature or luminosity and color, we can instead look at the absolute magnitude of the star versus the spectral type of the star. So let's draw that. For absolute magnitude, we're going to look at the absolute magnitude in the visual band, so we'll give it a V, and we're going to compare that to the spectral type of the star. Now, the absolute magnitude in the visual band increases in the vertical direction downward. So you're going to have negative numbers or small numbers on the top, and you're going to have larger numbers increasing downward. So the absolute magnitude increases in the downward direction. Spectral type is a grouping of letters that are a ranking of the star's spectra. And those letters are O, B, A, F, G, K, and M. Now there are other letters for L and T and the Y class, but the T and the Y class are generally for objects that are brown dwarfs, and Ys are for planet objects. So since this is a graph of stars, we're going to eliminate these categories of L, T, and Y. Now there's no reason why we use the right side of the diagram. We could have easily put everything on the left side of the diagram, so we could easily put absolute magnitude in the increasing vertical axis on the left-hand side, and we could have put spectral type down here at the bottom. But for reasons why you'll see in a minute, we're just going to leave it to the top and the right axes. So let's look at an HR diagram from your textbook. Here's an HR diagram from your textbook. Notice that on the horizontal axis, we have temperature, and that temperature is increasing to the left. Notice on the vertical axis, we have luminosity, and that luminosity, or the brightness at the surface of the star, is increasing vertically. Notice on the right-hand side, we see absolute magnitude in the visual band, and absolute magnitude in the visual band is increasing in the downward direction. And at the top, you will see your spectral classification of letters O, B, A, F, G, K, M for stars. So in summary, you can compare the luminosity of the star versus the temperature of the star. Or you can compare the luminosity of the star versus the color of the star. Or you can compare the absolute magnitude of the star versus the spectral type. Either comparison set will put stars on a comparative diagram called the HR diagram.